Hey there, IT 140 students. So in this recording, we are going to introduce the idea of loops. So in the previous chapter, you have learned about decision structures. So decision structures checked a condition, and if that condition was true, then we executed a block of code. Well, a while loop is going to take that one step further. We're still going to potentially check a condition, and then as long as that condition is true, then we are going to repeat a particular block of code. So if you understood the idea of if statements from the last chapter, then the idea of a loops are going to extend from that. So we have the idea here where we are going to drive around the block until a baby falls asleep. So maybe you've had to do this to get your child to fall asleep. So what we're going to do is we are going to come down here and we're going to check, hey, if the baby is awake, if that's true, then we are going to drive around the block. And we're going to continue driving around the block, and then each time checking, is the baby asleep? So if, is awake. So if the baby is no longer awake, we're not going to continue driving around the block. What we're going to do is we're just going to return to our home, okay? So that's the idea of a loop. So in this scenario, our first check, so we come down here and the baby is awake, so we're going to drive around the block. Next time through, baby is still awake, so we're going to drive around the block. And then as you can see on the third check, the baby is asleep. So what we're going to do in that case is we are going to return to home. Okay, so that's the idea of a loop. So again, a loop is a construct that's going to repeatedly execute the loop statements. We call it the loop body, while the expression for the loop is true. And once it's false, then we exit out of the loop and we go find what the next statement is going to be. We say that each time through a loop is called an iteration. And so here is an example where we're going to start out where we've got a sum that's going to be 0. We've got a statement to get the next input. So this is just some pseudocode. So we're going to get the next input. And as long as that input is not -1. So as long as we are greater than -1, so as long as we're bigger than -1, what we're going to do is we're going to get the sum, we're going to add it together, and then we're going to get the next input. So very critical piece of the logic here is whatever tested condition you have, there has to be a statement that updates that tested condition. So val is greater than -1, that's what we're checking. So there needs to be something in the body of this loop where we change its value. So in this case, we're going to read in an input value. We type in -1 to exit, and then we would have our sum accumulated, okay? So not only can we calculate the sum, but we can calculate an average. So we've got a sum variable just like before, a number variable of how many we have, and then again, we've got the get the next input. So again, we're going to loop until -1 is entered. We'll accumulate the sum. We'll accumulate the number of values we've entered. So every time through, we add 1 to num. So this tells us how many times we've executed this loop. And then again, we ask for the next input. Again, critical. You have to check and update the tested condition at some point in the loop. Otherwise, if you don't, you'll create what's called an infinite loop. So this would be really easy to see if we had this written out in code, because you're going to be continually asked for the next input. So it would never proceed to calculating the average and then printing that average to an output display. They then go through finding a specific value in a list. So they'll walk you through this. So what we're going to do is we're going to check each item against the value that we're looking for. And if it's a match, then we have found it. We're going to exit out. They also go through finding a max value. So a very common implementation, they'll walk you through that. Okay, so let's look at the syntax of the while loop in Python. So in most programming languages, Python included, the while loop is a loop construct that's going to repeat the body of the code as long as the loops expression is true. So the syntax goes while, so all lowercase, and then some tested condition. This tested condition is just going to be like your if statements. While x is greater than 0, or while we haven't found what we're looking for. So some tested condition here, just like an if statement. And then it gets terminated with a colon. And then the loop body is indented, and whatever we want to perform based on the loop's purpose. So that's one thing that you'll have to kind of work through as you learn programming is what's the purpose of my loop? Am I looping through a list to find a value? Am I looping through everything to display their outputs? As we saw in the last examples in pseudocode, am I looping to accumulate a sum so I can calculate an average? Anyways, we have our statements that are going to be repeated, and then keep in mind something inside of this loop body needs to change the tested condition. If we don't, then this is going to run forever. And as I mentioned previously, you may just see, constantly getting asked input, or you may not even see anything happening. So this is the format of the while loop. And then once our tested condition is no longer true, we actually jump out of the loop, and now we continue on with whatever is after the loop. So here is an example. They've got a variable called current power. It's a 2. User character is going to be y, and we are going to loop while the variable user character is equal to y. So this is called priming the loop right here. We've set the loop to make sure that it executes on the very first run. If we didn't, if this was anything else other than a y, this loop right here is never going to execute. Maybe perhaps later on in our code, we might use an input statement where we say user character, equals input, and then that would prompt the user to type something in. Anyways, inside the body of the loop, remember it's got to be indented after the colon. We're going to print what the current power is. We're then going to multiply it by 2, and then we are going to ask for a character from the user. It would be nice to have a prompt here, enter a character, Y is continue, N is quit, anything of that nature. So this will continue as long as the user types in a Y. So you can see the first time through they have a, so this wouldn't have actually been an input. So we would have a 2, so there's our first 2. We then multiply that by 2, so we've got 4. We typed in a Y, so current power is 4, so that gets printed. Next time through it'll be 8. We're going to continue with a Y, so we print out the 8. We take in N as the input, and so this is no longer true, so we're not going to print the next value. We're going to exit out of the loop and then print done. So just kind of like I stated a second ago, the while loop has to have some kind of condition where we are going to quit. So in this case, they're going to have a variable called user value, and the Sentinel value, or the value that is going to exit out of this loop, is going to be a Q. So we're going to have an input statement right here, enter in a character, and they are explicitly stating enter lowercase q for quit. If they type in a capital Q, if they type in anything other than Q, this loop right here is going to continue. And again, I've mentioned it earlier, the idea that if you do not have a condition that gets changed to make it so that it turns false, you'll have created what's called an infinite loop. So it's going to continually execute forever and ever and ever, and that is not good practice. Good practice makes sure that you have a properly terminating loop. So let's see down here. We have a variable called user year, so that's going to be a user input value. We have a year considered, and that is going to start out at 2020. So year considered, that is getting updated right here. User year doesn't change. it's going to be whatever the user typed in right here. So the idea of this one here, this is going to not be an infinite loop. And let's come up with a little table that we can run. Hang tight, let me get a notepad opened up. So we have a year considered variable. We know that it is 2020 to start out with. Years per generation, this is 20. And so we get some kind of input for the user year. So I'm going to make it nice and easy. Let's say user year is equal to 2000. So this will definitely start. It will execute the first time through because 2020 is greater than or equal to user year. So yep, that's a true case. And coming down here, year considered, we're going to take what we are right now minus years per generation, which is 20. So this was 2020. Now it's going to be 2000. Okay, great. So now we've got 2000. So is 2000 greater than or equal to 2000? Yes, it is. So we're going to handle that case. And then we subtract off 20 again. And we have 1980. So now we're going to check, is 1980 greater than or equal to 2000? The answer to that question is no. So this will then exit out. So again, big idea here is something about the loop condition has to be updated. If this line right here was not in here, then this would be an infinite loop. Anytime I typed in something greater than or excuse me, anything less than 2020. Okay, uh, again, some more examples. So we have a while loop where we're going to get the greatest common denominator. So the idea here is we're going to ask the user for a positive integer, ask them for a second positive integer, and then right here our tested condition is that num A is not equal to num B. So as long as they're not equal to each other, we're going to check if A is greater than B. If that's the case, then we're going to set A equal to A minus B. And again, this logic right here is just to determine the greatest common denominator. But what I really want you to see is we are updating the value of num A. We are updating the value of num B in this case. And so we have definitely done some updates to this tested condition. So at some point, this is going to provide a non-true statement, and then we will exit out of the loop. And that's it for that section. Section 4, they just talk about counting with a while loop. Again, we've already kind of seen it earlier, but since we know that a loop's going to execute a certain number of times, we know for sure that if we have some number, if I start with a condition of I being 1, and let's say this is 100, this would loop from when excuse me, not I is 1 until we get to 100. So this would execute 100 times. This is going to execute as many times as this value right here. What new programmers oftentimes struggle with is they question, when do I use a greater than, when do I use a greater than or equals, and so forth. If I want this to execute exactly 100 times, then this code right here would work. I like using ideas of having a counter variable. If I want to execute something for a certain number of times, I like having a counter variable starting at 1 and then going to the value using the equal symbol. But you'll see with lists in programming languages, their indices don't start at 1. So it could totally be possible that we start this with a 0. And if that's the case, so if I start this at 0 and I still want to execute 100 times, then I change it to this. Now I would go from 0 until 100, but this is going to go really from 0 to 99. That's 100 values. So there's multiple ways of structuring things. You just have to take into consideration the context for what you need to loop by. We could do something like this where we loop while a condition is met this way. So this is kind of wonky, where we're going to start out with 5. We're going to loop as long as I is greater than or equal to 1. Keep in mind, this would be true, right? 5 is greater than 1. And we have to decrease the value of I here. So this would be counting backwards. I would be 5 to start with. Next time through, it's going to be 4, then 3, then 2, then 1, and so forth. So this would be a reverse countdown. This example right here, this changes the tested condition of I by going by 2. So this would start out at 0, then 2, then 4, then 6, then 8, and so forth. So this would let us increment 50 times, where we are going every second I value. We'll see down the road here a potentially better way to write a loop where we're going to step by, say, 2s. Again, I kind of mentioned this earlier. Again, multiple ways of setting up the tested condition. What they are showing you here is that we could use a shortcut notation. I don't need to type I equals I plus 1. The shortcut notation is to do a plus equals 1. Both of these are equivalent statements. This is going to add 1 to the previous value, just like this does right here. Okay, next type of loop that we get here in Python, which is also available in almost every programming language, is called a for loop. So the idea of a for loop is we're going to say for some variable in, typically they say container here, typically it's a list. It might be something like a tuple or a string, but typically it's going to be a list data type. And what we do is we have access to the item in that list. Gets terminated with a colon. And then just like before, we have some kind of loop body. What is different here is there's no tested condition that we have to maintain ourselves. This is going to loop through each element in the container one after another. So the idea here might be we have a list of names, Bill, Nicole, John. I know it's a list because it's encased in brackets. And what this is going to do is, as I go through this list, Bill is going to be assigned to the variable name, and then I can use it here. Next time through, it's going to be assigned to the variable name Nicole. Next time through, it'll be the variable name John, and so forth. So this is a local variable that I have access to inside the body of the loop. So if I know exactly how many times I'm going to be looping through something, like a list data type, for example, here, then using the for loop is the way to go. Now, we could totally use a while loop to loop through this. That can be done as well, but it's not as clean code as this is right here. So they give just more examples. We could reverse the list. So we could use the reversed function if we want to go in the opposite order. Again, nice features that we could utilize. So as I mentioned a couple sections ago, if I want to go by 2s, there is a way to do that with a built-in Python function called range. The range function has a multitude of usages where I can provide it different amount of parameters, and then depending on what the parameters are, what the generated sequence will give me. So the range starts out like this. So if I say range, give me 5, it starts at 0 and will give you 5 values, and they're integer values. So I'm going to get the first one to be 0, and then I get 5 of them total. So 0, 1, 2, 3, and 4. Or I can specify the start value. So this is the inclusive start value. And then how many values that I actually want. So this would give me 0, and then I want 5 of them starting from there. So 0, 1, 2, 3, 4. Or I could specify, give me the values from 3 up to and not including 7. Let me back up. I said this gave me 5 of them, didn't I? Sorry, this gives me starting at this value and then I get the range up to, but not including this value. So that's why I get 0 to 4 there. This right here, this gave me 5 of them starting with 0. Sorry about that. These examples down here, these are going to provide us, again, start value, the upper bound, but not including it, and then how we're going to be counting. So this statement right here is equivalent to range 0, 5, their default by 1. But if I wanted to go by 2s, I'm going to get all the values going from 0 up to, but not including 5, in steps of 2. Or we could reverse the order. These things aren't as common because we saw earlier we can use the reversed function if we want to really reverse a list. But the range function, this gives us a nice way to step through a data set if we want to go, say, 1 at a time, or if we want to go, say, 2 at a time. Typically, the range function is used with a for loop, and here we go. So we have an input for the number of years. We'll ask the user how many years do they want to calculate savings and interest, and then I can go with the range function. So this is a for loop using the range function. So I'm going to start at 0, and then I'm going to go 1, 2, 3, and then up to it, but not including the last value that they entered in here. So next section just talks about the differences between a while loop and a for loop. Keep in mind that a while loop requires you to change the loop condition. So somewhere along the lines, I has got to become not less than 100 anymore, which means it has to become greater than or equal to 100. If that does not happen, then this loop will never terminate. So a while loop, you have to maintain the condition. Has to get updated somewhere in the loop body. In a for loop, you're guaranteed that this is going to loop a certain number of times. So very powerful. If you know that you need to loop a certain number of times, I would use the for loop with a range function. If I have a tested condition that's really going to be kind of conditional based on either user input or if I'm searching for a value in a list, and if once I find it, I'm going to stop looping, that should be reserved for the while loop. Oh, by the way, just like with if statements, you can insert loops within loops. So we call that nested loops. You've got a loop inside of another one. We commonly refer to the outer one, the first while loop that you get to. This is the outer loop, and then a loop inside is the inner loop. And what we're doing here is we're going to print all of the 2-letter combinations that are possible. So they're going to start with letter 1 being an A, and obviously that's less than or equal to 0. They're going to start with letter 2 being A, and again, that's always less than or equal to 0. And what they're doing is they're printing letter 1 and then letter 2. So starting out, letter 1 is A. So this is always A through this loop right now. And then A, we have A, which we get right there. And then letter 2, we're going to increment it by 1. So next time through this, letter 1 is still A, but letter 2 just turned into a B. So we get AB. So this loop is going to execute A through Z. This loop right here also will execute A through Z, but keep in mind what we are doing is we're going first letters all A's, printing out A through Z of them. The next time through, it's going to be a B with A through Z as well. So are there usages of nested loops? Absolutely. Again, this is just kind of a toy example of showing you how you can use a nested loop. All right, so the break and continue statements are often used in programming to break out of a loop or to continue a loop based on some condition. Typically, a break says, I want to stop this loop because I've found what I'm looking for. So typically, I'm looping through a list and we found something that we're looking for. A continue statement is often used because we're looping through. We want to handle particular situations, and if something doesn't meet that that particular situation, we're going to continue regardless of it. So let's take a look at the implementations here. So they're going to accumulate the cost for a meal. And the idea here is we're going to loop through. Tacos have a cost, so we've got a number of tacos we're going to have. We've got the maximum number that we can buy. The big idea I want you to see here is once your meal cost is equal to how much money you have, then we're going to break out of the loop. So a break statement gets you out of the loop. And then here's where you have to figure out what loop you're breaking out of. It's always going to be tied with the most inner loop that you're in. So that would break out of this loop. And then we have another check. So this was for empanadas. This is for tacos. So if our meal cost, again, is equal to our user money, we break out of the loop. So looking at our code, we definitely adjust the value of meal cost. So hopefully at some point, these conditions get met. Now, it could totally be possible that, we have code here that doesn't make that possible. So maybe this should be a less than or equal to user money. Typically, let me give you a kind of a better example. So we've got a list of data, so I'll call it data equals, I'm just going to do A, B, and C. And so what we might do is I'll call my variable found it. I'll call it found data. I'll make it equal false. So while found data is equal to false, we're going to loop. So we might be looping through. So let's say searched data equals, and we'll just do an input statement. So the user types in what they're looking for. So while found data equals false, you know what? I don't want to do a while loop. I want to use a for loop here. So for d in data. So I don't need this variable here. Sorry about this. I'm just kind of going on the fly here to give you a little bit better example. If the searched data is equal to d, if that's the case, then we're going to break out. And, we could say something like this, in list. I know that Python could give it to me by just using a built-in function, but I'm going to give you an old school way. So in list equals false. And then I know it's in there, so I'm going to set in list equal to true. And again, I don't need to loop anymore once I found it. If I know that it's in that list, then I can break out. And so then afterwards I can say if it is in the list, print, yep, it was in there. Otherwise, I can print, nope, not in there. Okay, so again, a little bit better usage of the break here that makes more sense to you. And again, I gave you the idea of the continue. So what the continue does is we might want to check, we want to handle, so in this case, again, we're checking our cost for tacos and empanadas. And the condition here is if the sum of those divided by the number of diners, if it's not divisible by an even amount, what we're going to do is continue. We're going to continue generating this until we have an equally divisible number. A better example of this. So let's say we want to accumulate which vowels are in data there. Okay. So let's say we want to accumulate the vowels. We could do an if, and if that if one, we don't really care about it, we could do a continue, which would continue the process of looping. In some programming situations, the continue is used. Typically in production code, we avoid using continues because it kind of makes the code more difficult to interpret and read. Breaks are definitely okay, especially when I'm going to be searching for something like I showed you here. Okay, last thing, so a little bit more advanced idea here is that we can use an enumerate function of a list, and that will let us get all of the elements of the list one at a time. So the idea here is we say we've got a list of numbers right here. The enumerate function returns back the index, which position it is in the list, and then the value associated with it. So you get two things there, the index and the value. The indices in Python, which most programming languages do, always start at 0. And then you can see that position 0 gives a 4, position 1 is 8, position 2 is a 10, and so forth. So this is kind of a nice to have feature if you needed access to both, say, an index and a value. Okay, a lot of stuff there. Keep in mind, when it comes down to it, you need to know, why are you looping? What is the objective of the loop? Here, I was trying to search for some data. If it was in it, great, I found it. I know it's in there. I'm going to break out of the loop. We saw some examples where we were summing up the values of a list. Again, we're going to loop the whole way, add them all up. We've got the sum at the end. So always keep in mind, what's the purpose of the loop? For loops are going to have built-in ways to terminate themselves. While loops, you have to maintain the tested condition in the body of the loop. All right, that's it for now. I'll talk to you next time.